Hello everyone, my name is Alex, and this is a walkthrough video for the Build a K-Nearest Neighbor model with p5.js project. Alright, so what are we doing in this project? We are going to use one of my favorite libraries, p5.js. It's a JavaScript library for visualizations to build a visualization for the K-Nearest Neighbor machine learning model. What does that actually mean? This GIF is what we're going to be working towards in this project, and this is the machine learning model in action. Most machine learning models, including the K-Nearest Neighbor model, its goal is to make a classification. Imagine you've created a character in Dungeons and Dragons, and you've already assigned its health and its strength and maybe some other stats, and you want to know, is this thing a mage or a warrior? That's what this is showing right now. This little moving this moving image is my mouse pointer, and the K-Nearest Neighbor model is classifying the location of my mouse as either a mage or a warrior. Imagine I put my mouse on 80 health and 20 strength. Well, what the K-Nearest Neighbor model is going to do is it's going to look at the K-nearest neighbors to that point. Let's say K equals 3. In this case, the three nearest neighbors it's definitely this point. This point's the second closest, and the third closest point is either one of those. It's probably this guy, but looks kind of close. Anyways, it looks at those 3 points, and it says, what classes are those 3 points? And the class with the most votes is what I'm going to classify my mouse pointer as. So in this case, it's going to be 2 barbarians or 2 warriors versus 1 mage, and so this point would be classified as a barbarian. So you can kind of see that as this is moving around, it's kind of flipping back and forth between barbarian and mage, depending on how close, or depending on the class of the points that are closest to it at the time. This is kind of a silly, fun example, but machine learning models have all sorts of real practical uses. The one example that we give in the machine learning course on Codédex is breast cancer classification. So rather than mage versus warrior and health and strength, let's say that you have a data set of tumors that were either malignant or benign. So that's our class. And then the features that we might be graphing here could be the size of the tumor, the texture of the tumor, any sort of measurement that you might take about the tumor. If you have a patient that comes in with a tumor and you don't know whether it's malignant or benign, you could use a model like this to say, hey, my mouse pointer is right here. Let me look at the nearest neighbors and make a prediction about whether this tumor is malignant or benign. Just one example, but kind of a nice one to show that this goes beyond, silly D&D classification. All right, let's jump into the project. What we are actually going to be building, this was like a little extension of the project to add fancy emojis and the axes and stuff like that. This is going to be the end state of our project where we have green points and red points. And again, our mouse pointer is moving around and we didn't draw any axes. So this is what we're going to be working towards. All right, let's jump into it. So over here on Codédex, I'm building a project here. And because we're using p5.js, this is a web development project. So we have an HTML page, we have a CSS page, we have a JavaScript page, and really we're only going to be working in the JavaScript file. It's important to set up your HTML page with the links to essentially load p5.js, but this is all form stuff, and we really don't have to worry about this other than making sure that it exists here to begin with. I suggest going to the P5 website, and they have this exact code right there that you can drop into your HTML file. But really what we care about is script.js. This is where all the magic is going to happen. And right now, this is basically the starting state that I always like to start with, just to make sure p5.js is hooked up correctly. If I move over here, you can see that I'm drawing a circle at my mouse position. The circle is the X location is the X position of my mouse, the Y location is the Y position of my mouse, and the circle is 10 pixels wide. I'm also creating the canvas, which is 300 pixels wide and 300 pixels tall, so we can draw the border of it. There you go, you can see. Okay, I'm actually going to get rid of this now that I know p5 is working correctly and that it is linked up to our HTML page correctly. And I'm going to come over here and grab our first big chunk of code. So what is this code doing? Step number 1 is we need to be able to create our data set. We need to be able to create 20 or 50 or 100 points that belong to a certain class, either red or green. And we are just going to randomize the location of the points. So that is what we are doing here. I've created a class named point. And when a point is created, it is given a random X location within the width of the canvas. It is given a random Y location within the height of the canvas. And its class is set to either 0 or 1. In a second, we will color all of the points with class 0 as one color and all the points with class 1 as another color. So that's creating a point. And then really the only thing a point needs to do is display itself. So we are going to display the point as a circle, 20 pixels wide and 20 pixels tall. And we're going to display it at its own X location and its own Y location. And then importantly, this is how we're doing the coloring. If its class is 1, we're filling the point with lots of red. And if it's not 1, meaning it's 0, we're going to fill it with lots of green. So that is our point. All it can do is it can exist and it can display itself. If I run my code here, nothing is going to show up because we have created the point class, but we have not actually created any objects of that point. So let's go ahead and do that. I'm going to grab this code. So this is the setup function. And again, this is going to, let me do that. A few lines there so we can see it. So this is going to create our canvas and create a test point and display it. So there it is. There's our test point on that run, and I can keep hitting run and it will keep drawing new random points in different locations. So that seems to be working great. But the thing is, we don't want just one point. We want a big array of points. We want 20 or 50 or however many we want in our initial data set. And so let's go ahead and do that. So I'm going to now, rather than just create one point, I'm going to create an array. And then I'm going to loop 20 times. And I'm going to put a new point in that array every time we loop through there. And then finally, in the draw function, and I'll talk about why we're putting this in the draw function in a second. I'm setting the background to a color, and then I'm looping through our points array and calling display on them. So I'm basically telling each point to display itself once it has been created. I actually think I made one small mistake. I think this has to be outside the setup function. Did I do that correctly? Don't think I did. There we go. Give me that. Yes, points has to be outside the setup function because we're using it in both setup and in draw. And so if I hit run now, you can see 20 points are being created. Small little detail here. We probably could have done draw. We probably could have displayed the points inside the setup function. But that's going to kind of change how things look once we start drawing points with our mouse pointer. And so I put it in draw. If you're new to p5.js, essentially draw calls every 32 times a second, basically. So technically these points are being drawn over and over and over again, just on top of each other. Okay, let's keep going from there. So the next step that we need to do is the model part of this project. We need to create the machine learning model. So the first thing we need to do is we need to say, given my mouse's location, what are the k nearest points? And again, I'm just going to use k equals 3 in this case. You could set k to whatever you want. It could be 5. It could be 11. If it's an even number like 10, you'll have to write some code to say, what do I do in the case of a tie? What if there's 5 red points and 5 green points are the closest? But again, not super important right now. All we're going to do for this step is we are going to, given my mouse's location, let's find the 3 nearest points. All right, let me come down and grab this code. All right, so we are going to write a new function called classify mouse. And what we're going to do is we are going to first create a distances array, and then we're going to loop through every point in our points list, and we're going to find the distance between that point and our mouse, then point number 2 in our mouse, then point number 3 in our mouse, and we're going to throw all of these distances into this array called distances. So I've created distances here, and then we're setting up our for loop. We're looping through every point in our points array. All right, so here's our code for actually finding the distance between our mouse and every point. We are creating a variable named distance. It is set equal to this very helpful dist function from p5. It just calculates the straight line distance between 2 points. And the way that it does it is you need to give it the x location of the first point, the y location of the first point, the x location of the second point, and the y location of the second point. And so what we're doing here is we're saying, we're looping through all of our points. So the first time the loop happens, this is the first point in our array, the x value, the first point in our array, the y value. We're comparing those 2 points to the location of our mouse. Then the next time that the loop happens, this will be the second point in our array, the x value and the y value compared to our mouse point, and so on and so forth. So that's our distance. Now we just need to add the distance to our distances array. That sounds pretty simple, but this is actually one of the slightly tricky parts of this project. We don't want to just add distance to our array, because if we did that, let's say my mouse is right here, and so the 3 closest points are that green one, that red one, and that red one. So if we just added the distances, we've now lost the value, we've lost the class of these 3 closest points. All we know is, hey, that green point was whatever, 2 units away, that red point was 1 unit away, that red point was 2 units away, but we don't know that that was green and red. And so what we're actually going to put in our distances array is we're going to put this object or this list or array that contains 2 things. The first thing is the distance itself, and the second thing is the class of the point associated with that distance. So now we're storing this point was 2 units away and it was green. This point was 1 unit away and it was red. This point was 2 units away and it was red. So we're keeping track of both the distance and the class associated with that distance. All right. After that, we need to sort the distances. Again, this is maybe a little bit more confusing than usual. Usually we could just use distances.sort, and that would sort our array of numbers. But because this array doesn't have just numbers, it contains this list of the distance and the class associated with that point. We need to basically tell it how to sort. And we're basically telling it, we want you to sort by distance. So the objects with the smallest distance come first after we sort. So again, slightly confusing, but basically it's a little bit tricky to sort because this object is more confusing than just a number. Okay, next. Now that distances are sorted, we want to look at the k nearest of those. And whoops, I've screwed this up. I want to sort outside of my loop. Let me go back and grab that code. The purpose of the loop was just grabbing the distances for every point, and once we get all of them, that's when we want to sort. And now that we have sorted, we want to grab let me indent this correctly. We want to grab the first k one of those points and count up how many of those are red and how many of those are green. Sorry, my indenting got a little bit screwed up there. So what we are doing here is there's probably a more efficient way to do this. I wonder if somebody else can get a more efficient way to do this, but we're creating 2 variables. Basically, we're going to count up how many of our closest points are green and how many of them are red. And again, remember 0, if they were class 0, that was green, and if they were class 1, that was red. So we're going to set these 2 counters at 0, and then we're going to loop through our 3 nearest neighbors, which are the first 3 objects in distances, and we're going to look at the class. So the class is in position 1, and if that thing was a 1, we're going to add 1 to this counter, And if it wasn't a 1, that means it was 0. So we're going to add 1 to this counter. So basically, we're just counting up the class of each point. Once we've counted up the class of each point of our 3 nearest neighbors, we know which one is bigger. Were there more reds or were there more greens? And that's what we'll do here. We will draw a circle based on classification. So let me go ahead and do that. My indentation got screwed up. There we go. So if there are more 1s than 0s, that means that our prediction is going to be red. If there were not more 1s than 0s, that means our prediction is going to be green. And then finally, we draw a circle at our mouse point using that color. If I run my code, this is still not going to work yet, and that is because we have not actually called classify mouse. And so the last thing, I guess I didn't put that in. I said all we need to do is call classify mouse. So let's go ahead and do that in the draw function. And there we go. You can see that as we move our mouse around, there are 3 red points close to the mouse now. So it's red, 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 still red. Let's get to a point where there are 2 of the 3 closest points are green. So that will be like down here. Now 2 of the 3 closest points are green. Now it's back to red. If we come over here, it should be green, and so on. So that is the essence of the project. Let me talk about some bonus challenges. So bonus challenge number 1, we've hard-coded a few things into this code. We've hard-coded 20 points into our data set, and we've chosen 3 to be our k for k nearest neighbors. So this might be a little bit better if we don't hard-code that. If you could, have a variable up here that's like num points equals 50, and just changing this value would change the number of points, and the rest of the algorithm would work, or the rest of the model would work. So that would be changing things like, here's where we've hard-coded a 20. That might be the only place. Is there any other 20 in here? That might be the only place that we've hard-coded it, to be honest. The other thing that we've hard-coded is the 3 nearest neighbors. So that's another thing that you could change. This is a cool extension. It can be a bit tough to eyeball which points are the nearest neighbors to your mouse. Edit your code so that the nearest neighbors are now highlighted, maybe with a yellow border rather than black. So as I'm kind of mousing over here, I've been saying, oh, those 2 green points and one of these other red ones were the closest one. But it's kind of hard to know which ones are actually the 3 closest neighbors. So you could edit this code so those 3 closest neighbors are highlighted in gold, or maybe something else happens with them. But basically just highlight which ones are the 3 nearest neighbors given the position of my mouse. Add your own style. So that's doing something like what I did way up here of, rather than just red and green, maybe create your own example. So I'm using the Dungeons and Dragons example, but think about another use case for a machine learning model, and you could edit your visualization to kind of show that. And then finally, what's the last one that I say? K-nearest neighbor models can work with multi-class problems. Rather than simply red and green points, what if you had red, green, and blue points? So this is probably the biggest change if you want to extend this problem. What if you had a 3rd class or a 4th class, or, an arbitrary number of classes? Extend the model so it doesn't just work with red and green, it could work with any number of classes. Cool. Well, thank you for watching this video, and hope you enjoy the project. Bye, everyone.